This lesson is for Advanced Algebra, Lesson 11.2 on Multiplying Polynomials. We're going to be using the extended distributive property to do area and volume problems. Students learned the distributive property back in Algebra 1, and hopefully they remember what to do there. For the extended distributive property, it's very simple. You're simply going to multiply two polynomials together by multiplying each term in the first polynomial by each term in the second, and then you add any like terms. So let's just do a quick practice question here. You do have the option of distributing the first term here to everything in the second. You could also take everything in the second and distribute it to everything in the first. When you're multiplying, I would suggest making sure that all of your polynomials are in standard form. It'll help make your multiplication and keeping things organized a lot more simple. I'm going to distribute an x to everything, and then I'm going to distribute the -7 to everything. So I'm going to actually kind of go in backwards order here. So first I'm going to take x times the first polynomial. And it's very important, students, that you actually say to yourself what you're doing. Obviously I'm going to say them to you here in the video, but you should be saying them to yourself when you're doing them on your own. So 5x squared times x is going to be 5x to the third. Now let me just show you the reason, because really you're doing 5x squared times 1x. The 5 and the 1 get multiplied together, and the x squared and the x get multiplied together. Remember the rules for multiplying with exponents. You add the exponents together when you multiply. So that's why that turns into 5x cubed. Now we're going to take x times -4x. So that's -4x squared. And x times 3 is 3x. Again, you don't need to worry about like terms here because it's multiplication. Now I'm going to do the -7 times everything in the first. I'm going to start on the left. -7 times 5x squared. It's -35x squared. Now I'm actually going to show you a little bit different way to do this problem. When I first did it, when I first learned, I was taught just to put everything in one big long line or one big long strip. And what I found is over the years it's a little bit easier to put them vertically in alignment with their like terms. It makes the adding of like terms a little bit easier, and that's just my opinion. If you want to write it all in one big long line or one big long strip, that's perfectly fine. But I'm going to put this -35x squared right underneath this one because I know that those are going to get added together later. So I did the -7 times the first term. Now I need to do -7 times -4x. Negative times negative is positive. 7 times 4 is 28. And so I'm just going to get positive 28x there. And then -7 times 3 is -21. I don't line that up with anything because there are no other constants. Now I'm going to add vertically. Anything that doesn't have anything above or below it just drops down. Here I'm going to do -4x squared minus 35x squared is -39x squared. 28 plus 3 is going to be 31x. And there we go. There's my answer. If we had to name this, just to do a little quick review from Lesson 11.1, we would say that this is a, and I messed up here, didn't I? Wrote a square when I meant to write a cube. So we'd say that this is a cubic polynomial with 4 terms. It's in x, and it has a leading coefficient of 5. So now I'd like students to try one on their own. Keep in mind that this one's very similar to what you're going to see on tests and quizzes in this chapter. Go ahead and copy the problem, pause the video, give it a try, and then you can check your answer. And so here's your answer. If you wrote it all in one big long strip, you would have gotten 9 products. And then some of them are like terms that you can combine. If you wanted to try it by lining up the like terms as you multiply, then you'd end up with 3 lines worth of material. Some of those are going to cancel out, some are going to combine, and you end up with a trinomial with a leading coefficient of 1. It's a degree 4, so we'd call that quartic, and it's in x. One thing that ends up working out really well for students if you're more of a visual learner is to do multiplication of polynomials by using the idea of area. What you do is you draw a box and you divide up the box based on how big the polynomials are that you're multiplying together. So in this case we've got a binomial times a trinomial. So we divided up the box horizontally into 2 and vertically into 3. Biggest thing that's difficult for kids here is trying to figure out what the total length is for each piece. Common mistake for kids is to say xy for this first length. And so just to illustrate why it's not xy, let's give these values with numbers instead of with letters. So if the distance here was 2 and the distance here was 3, would you say that the total length from top to bottom was 5 or 6? Would you add them or would you multiply them? And most students would agree once it's a number that they would indeed add. So to find the dimensions here we'd say x plus y, and on the bottom here we'd say a plus b plus c. So those are the dimensions. And that's one thing that they may ask you to do when they give you an area pictures. They might ask you to find what those dimensions are. Keep in mind that you're just going to have chunks of parentheses and you're not really going to do much with those. If they ask you now to find the area, you would go ahead and do the extended distributive property to get the answer. So you can use the extended distributive property, but I would recommend using the actual picture here to help you get the results. So if you look at the picture itself, this length here for this little triangle or this little rectangle goes from x to a, and so we would just say ax there for this rectangle itself. And if you continue that trend, we've got bx and cx. Now if you look at finding the area of this rectangle, it's a times y, so that's ay, by, cy. So there are 6 different products there, and if we add all of those together, that will be the area of the whole thing. Now it could be in dispute here on how you would write it in standard form, depending upon which letter you give priority. Clearly a and b come before x and y. So another way to write this in standard form would be to say ax and then ay, bx, by, cx, cy. I'd accept either answer as being technically in standard form. So let's try it again now in terms of volume. If you're working with a 3-dimensional shape and you do the volume, you would have 3 things that you need to multiply together. Keep in mind though, you can only multiply 2 things at a time. So students, when you're writing out your dimensions, make sure you don't try to do too much at once. So let's find the dimensions of this box. The vertical distance here would be a plus e. It's not wrong to say e plus a, it's just usually easier to put things in alphabetical order. The dimension all the way along the bottom here is again a plus b plus c, and then the width there is a d. I would recommend putting any single letters that you have for dimensions at the very end or on the far right. When students put them over here, they tend to make a careless mistake and distribute the d to everything, which is incorrect. So it's better to put it on the right, and then when students multiply here using the extended distributive property, you would just multiply by d when you're all done. So I want students to give this a try on their own, and then I'll reveal the answer here for the volume of the box without any parentheses in just a moment. And so the final answer is here. Basically what I did is I distributed a to everything, then I distributed e to everything, and then when I was all done I distributed a d to everything. There are no like terms here. We would want to put the a squared d term first because that's got a degree 3, and we do have a degree 2 there on this particular letter, so that's going to carry a higher priority than any of the others. All of the terms here are degree 3, by the way, because they all have a power of 1, and when you have more than one letter involved you would add to find the degree, but because this one has a square it would take a higher priority. The last thing we're going to talk about is another practical application of where the extended distributive property can help in real life. If you take a piece of paper or a piece of cardboard in which you know the dimensions and cut the corners off of each by some unknown amount, you can identify now the area that would be here by imagining that you fold up those flaps that have been created. So what's been created now is a 3-dimensional shape. If you folded up those flaps, now you'd have some kind of a box. Now clearly you'd have to do something to contain that box so that those flaps would be stuck together. But indeed you did take, by cutting off the corners here, and folding it, you did take a two-dimensional shape and turn it into a three-dimensional one. The trick to this one, though, is figuring out what the new dimensions are for the new shape that's formed after you've folded it up. So keep in mind that the original length all the way across was 150, but we cut off an x from either side. So the dimensions here would actually be 150 minus 2x, because there's an x cut off here and an x cut off over here. The same thing is true with the other dimension. An x is cut off here and here. So the other dimension is 100 minus 2x. Now if we multiply those two together, all you're going to get is the area of the bottom of the box. You would not get the total volume. The volume of the box would be created by you looking at how tall the box is now. And the height of the box is completely determined by however much you cut from the corners. And so that has to be x. So now if you were to find the volume, these would be the dimensions of the box. To find the actual volume, you would multiply the first two sets of parentheses together and then distribute by x when you're done. Go ahead and give that a try and pause the video. So if you went ahead and multiplied the first two sets of parentheses together, you'd get 4 terms. The middle two terms are like terms, so they should be added. Then you should distribute an x to everything, and then make sure that you flip everything around because you want to make sure to write it in standard form. So you just got a polynomial now that would represent the volume of the box as soon as you determine what the amount of the cut corner length was.